Hello everyone, so this video is about the K-means algorithm, which is an algorithm used in clustering problem or unsupervised um, learning, unlike the supervised learning where the data needs to be labeled with the target. Here you don't need any label, so the computer here will learn by itself to like grouping or clustering observation based on the features. So like linear regression and logistic regression, we need here the in Python some libraries, some modules and classes. Here, so instead of scikit-learn linear models, here we need cluster because it is a clustering problem. We import this class, which is Kmeans, for the matrix instead of what we saw in here, for example, in the logistic regression. Instead of accuracy, precision, instead of in a linear regression we used the mean absolute error, etc. Here we need the what we call silhouette score, and I will explain how to use it in a few minutes. Here we need also Seaborn in case we want to draw some graphs, charts. Here we need we don't need this actually, no need. We don't need this as well. Now the first thing to do is import our data, same thing, so we use panda.read csv. This is the path file, the file path, sorry, of which means the path of our file. Use the path to your file in your computer. So if you use this path, you get nothing. So you need to use the path of your data in your computer. Now let's run this code. So here are the data. Let's do this. Head, we have the profession, we have the income, credit card number, expiry and security code, and here is labeled data. But so here, since it is labeled, we can use the logistic regression, either it is a fraud or not, but we ignore this so that we can use the K-means, how it clusters data based on this feature. Let's say credit card number and the income, based on two features, how the model will cluster them. So what we need to select our features. Let's say we will use only the income and credit, so x equals those columns on df. Okay, now we have our x. Now actually we could apply directly this one, K-means. It is like we did with model equals, here K-means equals K-means, we use our like here, like this. If you write K and you press on tab on the key word, you will find this K-mean. So K-mean, here you tell the model that the number of cluster it is 2. It's like you give it this information. You say please split those data, those observation, into two groups. If I write here 3, it means I give it this information, split it or cluster them into 3 groups, and so on. Let's keep it 2. But instead of this, we will try to perform with different number of cluster, different, like from 1 to 5, different number, then we choose the best one. This is how we decide which is the number of cluster we will use in our model. So how to do this is first to create the inertia. Inertia is the actually the distance from the any observation to any cluster. So it is the distance between any point to the center of a cluster. the center of cluster called centroid. So this distance we try to minimize it. That's the objective of Kmeans. So we create initial, but here not for a specific number but for range, for k in range 1 to 5. So we have here Kmean equals Kmeans and cluster is k. So random state is the same thing, Kmean dot fit for our x, initial dot append Kmean initial. So exactly this code tells the model to try different k 1 until 5, which means try the number of clusters 1, try with number 2, 3, 4, 5. Then in the end we will get a graphics that shows the relationship between the number of clusters and the inertia, which is, as I said, the distance of the average distance of the observation from the centroids or the center of each of the cluster. Now let's run this code and you will see this graphics. Okay, using this graph actually helps us. This is inertia and this is the number of cluster. It helps us to decide which is the best number of cluster here. And how can we know? We have this it is elbow, actually it is elbow, this method elbow. So when you see the slope is getting smaller, you stop there. For example, it forms something like an elbow here. As you can see, it is like an elbow. When this happens, this is the best cluster actually. So here, as you can see, adding one cluster from 1 to 2, the inertia dropped with like a big amount. So it drops drastically, which means that we really need to use 2 better than 1. But let's compare now from 2 to 3. When we added one cluster here, the inertia didn't drop actually like in a way that it optimized the model. No, it drops, but the difference is too small, so we just ignore it. This is why elbow is good. So use when you want to decide the number of a cluster, you use this method of elbow. You draw this graph using this code. As I said, create the inertia, different inertia for different Kmean from 1 to 5, for example. That's just an example. Then you plot here the our k and the inertia. We get this graph. When you see something like here, like an elbow, you get the best k actually. So for our case here, the best k is 2. The number of cluster is 2. So since we know the best is 2, we have actually other method to get directly the best, but let's keep it simple and know how to use actually the Kmeans. Okay, so Kmeans here, let's create the model. Is the Kmeans, our Kmeans here. Okay, tab, we choose Kmeans. The number of cluster, we saw that from here it is 2, so we choose 2 here. Random state doesn't change things here. Kmeans dot fit x, here we fit our model on the data. Control enter. Now this is our model. Now let's label our data. So using this, actually it helps us here dot head. Using this help us to label all our observation, like depending on the cluster. I give my data a cluster. So here I will assign each observation to its cluster according to this model. So let's run this code. And as you can see, the first individual, which is who is a doctor, his income, credit, etc., belongs to the cluster 0, 0 for this, and then here it belongs to the cluster 1. Now we can draw also graphics that shows the centroid and the um, data point where it belongs, actually which cluster. Control and enter. Okay, that's good. As you can see, we have those the centroid, or the center of the cluster. We have the cluster 0, the cluster 1, and as you can see, the majority are here in cluster 1, and here we can get the score. Actually, the silhouette score. So is the silhouette score is the matrix used to evaluate the model Kmeans. So how it works, actually, it measures how accurate or how close the observations to the cluster compared to the neighbor cluster, to the next cluster. And here the this measures actually is between -1 and 1, and the more it gets closer to 1, the better is the model, which means if you get something like 1 or close to 1, it means the model is performing well. So let's check it here. Right, that's good. So the silhouette score here is 0.99, which is very close to 1, which is perfect. Actually, the model is assigning each observation to its correct cluster. And finally, as the other models, let's predict the cluster of a new point that we don't know to which cluster it belongs. So we have a new point. This is his number. The credit card number, I guess. So we have the income and we have the credit card number. Okay, so let's change it like this. So this is his income, this is his credit card number, and now let's predict if this individual belongs to the cluster 0 or to the cluster 1. So this one belongs to the cluster 1. Now let's try this credit card number. So now this one belongs to this cluster 0. So this is how the machine, the computer, now can predict any new data and add it, assign it to a specific cluster. We can have many clusters, more than 2. Then as the data analyst, you can decide, or you can explain what each cluster actually means depending on the context. So this is how clustering using Kmeans algorithm is performed on Python. Thank you everyone, and wishing you good luck.